All right, we like to think of Unit 7, Lesson 5 as sort of a palette cleanser, measuring and classifying angles and triangles. So for some of my right-brained creative people, you're going to love this because it is not about algebra. Students will be able to use a protractor to draw and measure angles. Now, if you are remote, you've already been provided with a 6-in-1. If not, you'll get one in the classroom, and this has a protractor on it. All right, so this part that is drawn in is the protractor. On the 6-in-1, it's right in the middle. Protractors are used to measure angles or draw angles of a particular measure. You will notice there are two arcs of numbers. Numbers starting at 0 on the left are on the outer arc. So on the outer arc, the one that's further away from the center, it goes 0, 10, 20, 30, 40. And on the inner arc, they start at 0 on the right and go 0, 10, 20, 30, 40. It all comes down to which side of the angle you are measuring from. So the base of the angle for the first picture is on the left. So when we look at this angle, we are going to start counting from the left because that is where the left side is pointing, right? The bottom is pointing to the left. So we're going to count as we go up and go 10, 20, 30, 40, 50, 60, 70, 80, 90, 1, 110, 120, 130, 140, 140 degrees because we are opening from left to right. This particular one, just slightly before, it's actually two little lines before. So this one looks like 138. So 138 degrees, and you will notice that it is larger than a 90-degree angle. We call that obtuse. A 90-degree angle would be if your second ray were pointing straight up at 90 degrees and you had a perfect corner here. That is a 90-degree angle. We went past that 90-degree mark to 138. Supplementary angles are a pair of angles with a sum of 180 degrees. What is the supplement to your answer from number 1? So this is a definition. Supplementary angles, a pair of angles with a sum of 180 degrees. Your answer to number 1 was 138 degrees. What is the other angle that would be called the supplement if it has to add up to 180? So 138 plus what number would add up to 180? The other number would be 42 degrees, and we would call that the supplement. It is supplementary, or the pair are supplementary, and because we were asking about 138, the supplement to 138 would be 42 degrees. Use a ruler and protractor to draw an angle that measures the supplement of number 1. So we're going to draw a 42-degree angle. So we're going to grab our 6-in-1, and we're going to use just the straight edge to draw a ray. Your ray can be pointing to the left or to the right. It doesn't matter, but you have to decide that. So I'm going to put my center on the left, and I'm going to put mine pointing to the right. Now, when I put my protractor back on, there is a hole at the center of the protractor, and that needs to go on the little dot that you drew that you're going to call the center. And you can see, if I kind of twist mine, you can see that ray underneath it. My goal is to line up that little dot inside the center of the circle and line up the base of the protractor on top of my blue ray so that I can't even see it anymore. Can you see how the arrow is way over here sticking out? Okay, that way I know that I'm lined up correctly. My arrow on the ray is pointing to the right, so I'm going to count up from the right, 10, 20, 30, 40, and then two little teeny lines past 40, I'm going to put a dot in that arc, and then I'm going to move my 6-in-1. And I'm going to connect that center point that was inside the little opening, the hole, and I'm going to connect that with the straight edge of my 6-in-1, and that's going to create a 42-degree angle. Now, if you need to go back and watch this piece again with a piece of paper and your 6-in-1 and your pencil, you can try this over and over and over again. If you want to see if you did a good job, place your 6-in-1 back on top of the circle, the little dot on the left end. Make sure that you are lined up on top of your ray and see if that line does in fact go through the number that is two little lines past 40. Next, number 4. What is the measure of angle ABC? Now this time we have sort of a traditional looking protractor that you might see on a standardized test. And underneath it, we can see that there is a ray pointing to the right with a point labeled A. And then the vertex or the corner B, that's where our open circle would be on top of. And then it's pointing up through two numbers. It's pointing through 60 and it's pointing through 120. Now you have to be the person that says, I noticed that the bottom ray is pointing to the right. So I would count up from the right 0, 10, 20, 30, 40, 50, 60 to get to the second ray. So this is only a 60-degree angle because I was counting from the right, starting with 0 at the right. Complementary angles are a pair of angles with a sum of 90 degrees. So that is a second definition. What is the complement to your answer in number 4? So we're asking 60 degrees and what other number would give you a sum of 90 degrees? And 60 and 30 degrees is the other one, right? 60 and 30 would add up to 90. So we would say 30 degrees is the complement because we were adding up to 90 this time and not 180. Now, if we go back through, you will see there are two other vocabulary words as well that have not been highlighted. This angle is obtuse. Those are any angles that are larger than 90 degrees. Then down here, we also have this angle is acute. Acute angles are angles that are smaller than 90 degrees, such as our 60-degree angle here. So acute, less than 90 degrees. So technically speaking, we have a lot of new vocabulary here already. All right. Based on angle measures, there are 3 types of angles: acute, obtuse, and right. And I can remember my mother calling me one night saying she was watching the TV show, Are You Smarter Than a Fifth Grader? And the question was, which of these does not belong? Acute, obtuse, equilateral, or right? And I said, well, acute, obtuse, and right are all ways to name a triangle based on their angle measures. And equilateral is a way of naming a triangle based on its side length. So the one that doesn't belong is equilateral. And my mother thought I was a genius. And I said, really? I teach 7th and 8th grade. I certainly hope that I know this one. She was still very impressed. So I let her be very impressed. Use a ruler and protractor to draw an acute triangle with the measures 60 degrees, 45 degrees, and 75 degrees. Now, this is going to be an acute triangle. All of the angles measure less than 90 degrees. Which one do we draw first? Typically, I like to draw the largest angle first, so I'm going to start with the 75-degree angle. I'm going to draw a ray, and I'm going to decide that I'm going to put my point on the left, and I'm going to put my arrow on the right. Doesn't matter. Okay, you could do it opposite. It's just it wouldn't match the video. And I need 75 degrees. So I'm going to put my ray along that bottom line. I'm going to make sure that I can't see it. I'm going to make sure that the dot that I drew is inside that little circle. I'm going to count up from the right. 10, 20, 30, 40, 50, 60, 75. I'm going to put a little dot, which is between 70 and 80 at that slightly longer mark for 75. I'm going to pick this up and I'm going to draw just a nice long ray that goes through it, because I actually have no idea where the whole triangle is going to come together. I'm just sort of guessing. And so I may extend my line, and that's all right, because it will come together exactly where it is supposed to in a minute. It will make complete sense. So right now we have a 75-degree angle here, but we're trying to make a triangle. We're trying to make something that closes. So in order to do that, I'm going to go to the other side of my ray. And this time I'm going to put a dot there over my little arrow and say, this is my new endpoint. And this time I'll do my 60-degree angle. Doesn't really matter. You can do any one of them. I'm going to line up that hole in the protractor on top of my new point, my new brown dot. And this time from the left, I'm going to count up 60. So from the left, 0, 10, 20, 30, 40, 50, 60. And I'm going to put a dot at 60. I'm going to pick up my protractor. And I'm going to remember that I'm now working with these brown dots. And so when I go to connect the brown endpoint on the right through the brown dot that I just made, I'm going to get here my 60-degree angle that I was trying to make. Anyone want to take a guess what that mystery angle up at the top is? If we did this right, we've done the 75 and we've done the 60, that top angle should measure 45. So I'm going to turn my paper so that I have a new side on the bottom. I can change my colors if that helps. In the beginning, it might. This is going to be my new center point. And I'm going to put my protractor on and make sure that I got a 45-degree angle. So if I put it so that the base is to the right, I've got that new green circle right in the center. The base is to the right, and I'm making sure that I'm overlapping it. And I'll tell you, I actually got about 44. I did not quite get 45. However, we are going to let you be off plus or minus 2 degrees as we start this. Part of the reason mine is off is when I switch to marker, it's a little bit thicker, but we are going to label it as the 45-degree angle. What probably happened is that my earlier angles may have been off by half a degree, and that would make my final angle potentially off by a whole degree. But as long as you are within 2 degrees when I measure your drawings, you will be absolutely fine. All right, so next, we're going to try to draw an obtuse triangle. Again, I usually start with the longest one. Actually, it doesn't matter. So if you wanted to start this time with something else that's not the longest one, we can do that too. 50-degree angle. So I'm going to draw a segment. It can be whatever length you want, short, small, but I try to do something sort of medium. I try to do just like a couple inches. I'm going to put a point on the left. I'm going to pretend the arrow's on the right, and I'm not going to draw the arrow this time. I'm just going to pretend that it's there. And I'm going to do a 50-degree angle. So I'm going to put my protractor on that little circle. I'm going to make sure that the bottom lines up on top of my ray, and I'm going to count up from the right, 10, 20, 30, 40, 50, put a dot on the 50, move my protractor out of the way, and draw a segment that goes up through that. And here is my 50-degree angle. Now on the right, let's do the 15-degree angle just for the heck of it, because it doesn't actually matter. We're still going to get a triangle that works no matter what. This time, I'm going to put a dot on the right end, and I'm going to count this time from the left, because this time the ray is on the left side of that dot, and I'm only counting up to 15. So 10 and then another 5 would be right here. And it's actually, my dot's not very dark, but from the right end this time, going through that new point, and I've got right here my 15-degree angle. And so if I did this correctly, the 115-degree angle should be up here. And I would rotate my page, and I would put the protractor on that new dot, which maybe I put a different color just to make it easier. And I'm going to line it up with my base that is pointing to the right. I'm going to count up from the right, 10, 20, 30, 40, 50, 60, 70, 80, 90. I've got to go past 90, 100, 110, and I actually only have 114. And so I am off by 1 degree, which is okay. You can be plus or minus 2. We are still going to label it as 115 degrees because that is what the angle is supposed to be. We are very close. And so honestly, you can see I'm ending up 1 degree off, which is perfectly within the acceptable range. Now let's just say, for the heck of it, you had drawn the 115-degree angle first. Okay, so I'm going to draw an extra segment over here on the right, and I'm going to put my protractor with the dot on the left, and I'm going to measure up 115 degrees. So all the way up here is 90, 110, 115. Notice it is open more than a 90-degree angle. And here's my 115-degree angle. On the right-hand side, let's go over and do the 50. I don't know. Doesn't really matter. I'm going to go on the right side. I'll make my dot just a little bit bigger there on the end point. This time I'm counting up from the left. 15 is right here. Nope, not 15. 50. I was going to do 50. Sorry. 10, 20, 30, 40, 50. And then I'm going to go from here, here. And so something went terribly wrong, right? They're not connecting. The only thing that went terribly wrong is that I haven't drawn them long enough yet. And I got a little bit wiggly, but if I continue drawing this, you can see that it would, in fact, eventually intersect with that one on the left. It's just going to take a while. And I did happen to overlap my other drawing, but way up here is my 15-degree angle. So what you will notice is that you will get triangles that are called similar. They are the same shape. This one has 50 degrees, 15 degrees, and 115 degrees. It just happens to have smaller side lengths than my other one over here, which is 115 degrees. This one was 50 degrees, and way up at the treetop was the 15 degrees. They are similar triangles. So they are both obtuse. They both have a 115-degree angle, but they are also called similar because they have all angle measures congruent. Congruent is another word for equal. all of the angle measures are the same, making those two shapes similar, even though one looks way huge compared to the other. I could put this little teeny tiny one on the photocopier, and I could ask the photocopier to enlarge my triangle, and I could get this one over here on the right. The angles would all stay the same, just the side lengths would get bigger. Last but not least, use a ruler and protractor to draw a right triangle with angle measures of 60, 30, and 90. A right triangle, one of the three angles, is exactly 90 degrees. If you find that you are drawing a 90-degree angle, it is easiest to draw it first. So draw yourself a segment, put an endpoint on one end or the other, and your 90 degrees is straight up. So a perfect 90-degree angle has a little square in the corner, and that tells the person looking at your diagram that it is 90 degrees. You could write 90 degrees as well, but we use this symbol to convey that it is a right angle. It's also going to be part of a right triangle. So I'm going to go to the other end point, and this time I'm going to make my 60-degree angle. I'm going to count up from the left because the line is pointing to the left. 10, 20, 30, 40, 50, 60. And I will connect my endpoint through that 60, and you will notice I did not intersect. I'm simply going to extend my first side a little bit longer. So here's my 60 degrees. And if all went well, I can turn my page, and that remaining one should be 30 degrees if I did it right. So here's where they intersect. Here's the remaining angle. And I'm getting about 31. So that's pretty good, within my plus or minus 1 degree. So this one I would label as my 30-degree angle, and I have a 90, 60, 30, 60, 30, 90, and it is a right triangle. Now, had somebody else in the room drawn their first segment longer than mine, their triangle would have ended up bigger. Had they done their 60-degree angle first instead of their 90, they would have gotten something with a different orientation. So if I put here just some random segment, and I do my 60-degree first, my arrow, my ray pointing to the right, so I'm going to count up from the right, 10, 20, 30, 40, 50, 60. And I can always see that that 60 is smaller than a right angle. It did not open up high enough to be 90 degrees, so I did use the right number on the protractor. On the right side, I could do my 30-degree angle. So this time counting up from the left, because the ray is on the left side of that dot, I'm just trying to center it and line it up. There we go. 10, 20, 30. And this time I'm going to get a teeny tiny triangle, but it's a 60 and a 30. And up here, if I did it correctly, is my 90. Rotate the page and you can say, oh yeah, hey, it does look like a 90-degree angle. And if I put my protractor on there, I got about 89-ish, 89 and a half maybe. And that's my 90-degree plus or minus 2 degrees. So I have a right triangle. Again, these two are considered similar. They're not the same size. They are the same shape. And I could put the smaller one on the photocopier, ask it to make the diagram, or ask it to make my copy larger. I could make an enlargement and get this one. I could also put this first one on the photocopier and ask it to make a reduction. I could make it smaller and get this one. They are still similar because all of the angle measures are congruent, and they are both right triangles. They are both 30, 60, 90.